So this was the hardware we designed for 1985 experiment. At the bottom of this part here, you see a superconducting chip. If you look at Google's quantum computer, it's sort of the same in principles, but multiplied on a scale of 100. In the mid-80s, the idea that you could make a quantum computer do problems that would not be reachable by a classical computer was completely unknown. There were no experiments that would test quantum mechanics on the scale of an electrical circuit. During my postdoc with Professor John Clarke at Berkeley and in collaboration with John Martinis, that was the purpose of our experiment, to test quantum mechanics on that macroscopic scale. There were two possible results in that experiment. Suppose that these macroscopic circuits would not have obeyed quantum mechanics. We would have seen a boundary between quantum physics and classical physics. The other possibility was that the mystery of quantum measurements would remain, but we would see that big objects are not doomed to behave classically. You can actually isolate them sufficiently that they will express their quantum nature. When we found that the result of the experiment was in some sense that quantum mechanics was working at the macroscopic scale, there was a realization that we could use these macroscopic quantum systems to make an artificial atom. Atoms on which we could put wires. The superconducting artificial atoms that we made in the mid-80s are the basis of Google's quantum chip today. To see this journey from a single experiment into an industry is quite fascinating. What is remarkable is that apparently the building of a very large-scale quantum computer doesn't seem to be forbidden by the laws of physics as far as we can tell. Today, at Google Quantum AI, for the first time, we have done an algorithm that leads to a verifiable result that can essentially not be obtained by a supercomputer. Even better, this quantum echoes algorithm is a pathway to real-world applications. It's an important milestone towards making the quantum computer a useful tool for instance, chemistry or material science. This announcement for me is very important because it completely resonates with the motivation we had 40 years ago when we started to do these foundational experiments. Because in the end, what makes all this interesting is the fact that you are trying to access some fundamental truth about nature. It's when you discover that nature has been cleverer, more clever than you.